This session, I'd like to do simultaneous linear equations with you. This part of the syllabus is it's actually not too tough because there's a system of rules that you can apply in order to solve these equations. What do we mean by simultaneous linear equations? Let's first of all just put our heading down, and we've got simultaneous linear equations, right? Simultaneous means done at the same time. Linear means there's no powers other than 1 in the equation. Oh, an equation, solve for x. The difference here is that we are solving for x and y. There's two variables that we solve for, but we solve for it simultaneously. In other words, at the same time. Well, you could argue the point that if you have something that looks like this, x plus 3y equals 5, and 2x minus 6y equals 2, you could just make x or y the subject of the formula and just put them equal to each other, couldn't you? All right? So you could say, well, therefore, let's say x is equal to 5 minus 3y, and over here, x is equal to 6y plus 2, 2x is equal to, and x is equal to 3y. And now I could just say, therefore, 5 minus 3y is equal to 3y plus 1, and solve for y. And then, to find x, back substitute my answer into any one of the equations. Same thing, right? Let's just look at that particular equation and find the x and the y value. But what are we looking for? We're looking for an x and a y value that make both equations true, right? So in this case, let's have a look at this. First of all, we've got two methods of this. Method A is called elimination, and part B is called substitution. Right? Elimination and substitution, and they will ask you through this method or by this method or using the process of this, solve the equation. If they don't stipulate it, well, then you're up to you to choose, and you choose the one that you feel the most comfortable doing. All right? Sometimes substitution is actually very quick and easy. Sometimes, however, substitution can lead to well, let's say a lot of fractions and quite a big mess up. It just depends. Okay? Let's have a look. All right? Let's look at it like this, and we say, right, we'll take the equations that we've got. 3x equals 22 minus 2y, and this equation, 2y is equal to 36 minus 10x. All right? Now, first of all, can you see here that we've got two equations, all right, with two unknowns, an x and a y and an x in it, right? We're looking essentially for an x and a y that make both true. Okay? So, yeah, for those of you who spotted it, that is a coordinate pair. We're actually looking to find where the two graphs intersect. All right? Now, that, as you know, is in the graph side of it, in functions and graphs. We're going to look at that in more detail at a later stage. But bearing in mind that the two simultaneous equations give us two values from two unknowns. And yes, you can expand it to say if I've got 3 equations and 3 unknowns, I can solve those as well. All right? There's various methods for solving those. Most of those are not in the syllabus that you do. You'll deal with those if you do AP Maths or if you go to university and do maths there. All right? Because we need different techniques for that. Okay. Right, now let's have a look here. All right? How do we solve? Let us say that, first of all, we are going to tackle the elimination method, right? Elimination. Well, what does elimination mean? It means get rid of, doesn't it? Eliminate. So we're going to get rid of one of the variables. So we choose step 1. okay, always write in standard form. Okay, now standard form, all right, is something times x plus or minus something else times y equal to some number. Okay, so there's something ax plus or minus by equal to c. Okay, that is the standard form. Okay, we always write it like that. Okay, so first off we say, right, 3x I've got to bring to the other side. So step one is write it in standard form. Let's have a look, and we say, right, therefore 3x plus 2y equals 22, and 10x plus 2y is equal to 36, right? This is my standard form, isn't it? Because in each case I've got something times x, in y I've got plus something times y, it could be minus, equals a number. The other one is the same. We write them in standard form, all right? Step two, okay, would be remove fractions if we have any. I'll deal with those later. Okay, so let's say remove fractions if we have any. Okay, so we'll get rid of them if we've got them. Step three, this is where you get to choose. Okay, it says, or I've said, choose a variable that you want to remove. Okay, okay, well, in other words, what do I mean? I mean, say I am going to get rid of the x, or I'm going to get rid of the y, right? Now, there's a series, you have to make an informed choice. You will get the same answer no matter which way you do this, but you have to make an informed choice, okay? Don't choose something that's going to make it difficult. Don't choose something that's going to introduce fractions, etc., etc. Let's have a look, right? So over here, I'm going to do it both ways, all right? I'm going to just decide to do both of them, just so that you can see, all right? First of all, I'm going to say, right, here we are. I've got 3x plus 2y equals 22, and 10x plus 2y is equal to 36. Now, another thing, I could simplify straight off here, couldn't I? And I could say, hang on, I can divide that by 2, can't I? You can simplify, okay? Because remember, x plus y equals 5 is the same as 2x plus 2y equals 10, all right? So you may simplify at any point, because technically you're not changing anything, you're just simplifying it. Right, so let's have a look here. Let's now say, okay, choose y. Choose to eliminate y. Okay, why did I choose that? It's no pun. Because both of those are 2. And I know that I'm going to add or subtract. So I'm going to choose y. Therefore, I say, and I now write them like this, equals 22, and 10x plus 2y equals 36. I label them equation 1 and equation 2. All right? I then say to myself that the next thing I'm going to do is I'm going to, as soon as I've brought this down a little bit, okay, my next thing is to say, right, now how do I get rid of, chosen y, okay, we have chosen to get rid of this variable because they're the same. Now, I can only add equation 1 plus equation 2, or I can subtract 1 minus 2 or 2 minus 1. It actually makes no difference. All right? So in this case, I want to get rid of y. What do I have to do? I have to take equation 1 equation 1 and subtract equation 2. What happens? I get 3x minus 10x plus 2y minus 2y is equal to 22 minus 36. Correct? That's what I get. So what do we say now? Okay, right. That is equation 1 minus equation 2. Okay. Usually we call that equation 3. All right. So now I simplify this and I say that's minus 7x is equal to 22 minus 36 minus 14, and x is equal to plus 2. Now back subs x equals 2. What do I mean? Well, as always, go to any of the equations that you've got. Let us take 3x plus 2y equals 22 and solve for x. Therefore, 3 times 2 plus 2y equals 22. 6 plus 2y equals 22. Therefore, 2y is going to be 22 minus 6. Therefore, y is going to be equal to, and if you do 22 minus 6, what do you get? 18, 19, 20, 16, yeah, and 2 divided is 8. Therefore, my coordinates are 2 and 8, right? There you can see, what did we do? We chose the variable that we wish to eliminate, all right? Now, if I'd have done it the other way, okay, so let me get my equations. 3x plus 2y equal to 22, and 10x plus 2y equals 36, okay? Let's say choose x. Let's say I make a mistake in my choice. Well, not a mistake, but I say choose to elim x. Right, I've got 3x plus 2y and 10x. The x's are not the same. So I now have to introduce a step, okay? And that is step 5. I'm going to go through step 4, which we did. Okay, we manipulated it to get the same. Okay, I know step 4, actually, I haven't. Step 4 is manipulate the equation to make sure the chosen variable. Manipulate the equation to make sure the chosen variable can be eliminated. Okay? So in this case, I need to say, I've chosen x. One side has got 3x, the other side has got 10x. How do I get the x's to be the same number so if I add them or subtract them, they disappear? Quite straightforward. I multiply this equation, equation 1, equation 2. I say, right, equation 1 multiplied by 10 gives me 30x plus 20y equals 220. And we can call that equation 3. And multiply equation 2 by 3. So I get 30x plus by 3, 6y is equal to 36 times 3. Okay, 36 times 3. All right. Now can you see what I've got over here? All right. We have got, that's a 30 and that's a 30. All right. Let's just multiply those out. And calculator. And what was it? 36 times 3. 36 times 3 is equal to 108. Equals 108 over there. All right. So what have I got now? We've got that. Therefore, now I want to get rid of x. So x is chosen. So I make sure that 30 and 30 correct. Now step 5. Okay, write the equations, let me just, it's not just picking that up nicely. Write equations like this, under each other, okay? You write them under each other, okay? Okay, so what I would do is I would say 30x plus 20y is equal to 220, and 30x plus 6y is equal to 108. Now, you can call that still 1 if you like, and this one 2. I do 1 minus 2 is equation 3. That means my x is gone now, doesn't it? 30. That means I've got 14y equal to 220. 220 minus 108, okay, is equal to 112. And y is going to be equal to, okay, I've got 9. I've got an error in there somewhere. But anyway, okay, I'll go through. Let's just go through. 3x plus 2y. Did I write it down right? 3x 22. 10 plus 2 is equal to 36. Yep. All right. Come here, you. Multiply by 10, so it's going to be 220. Multiply that by 3, 6. 36 times 3 is equal to 108. All right. 108. Right. 3, 6, 108 minus 220 be equal to that. And I've got here, okay, I'll have a look at that one, and I don't want to waste time on it. I'll just come back to it in a few moments and we will sort it out. But the process is identical, okay? Apart from the silly mistakes which one makes here and there, all right? Let's just have a look at this one, all right? Let's introduce a fraction into the situation. Let's say they give us x over 2 plus y over 3 equal to 10. And x equals 16 minus y over 2, okay? What do we do now? Well, we still write it in standard form. Here's the x and the y, all right? Here's the x and here's the y. This one is not in standard form, so we must write it in standard form, which is x plus y over 2 equal to 16. Okay? Right, so what do we do now? Well, first of all, we say to ourselves, this is a bit of a mess. We have done step 1, all right? Remember, step 1 was we are going to use we're going to use the elimination method, okay? Yeah. Okay, we'll use the elimination. All right, step 1, standard form. Step 2, okay, we've got fractions, okay? What do? We remove fractions. Remove fractions, okay? You don't want to deal with them. Nobody does. Let's check. What do we do here? I multiply by the LCD, don't I? Okay? Multiply by the lowest common denominator to get rid of it. What is the lowest common denominator in the first one? It is 6. In equation number 1, it is LCD is equal to 6. In equation 2, the LCD is equal to 2. Let's multiply by 6. Now, here's where I say, please, guys, do it. 6 over 1 times 6 over 1 times 6 over 1. There's the biggest error. People forget that one. Okay? So what do? I go forward like this. Okay. I can now say that cancels there and gives me a 3. So it becomes 3x plus, that becomes a 2. 2y is equal to 60. And over here, 2x plus y is equal to, multiplied by 2, is equal to 32. All right? Remember this step. 2 times 2 times 2. It's the safest way to do these. I promise you it is. All right? Now we say, right, choose a variable. Right? But hold on, none of them are the same. There's a 3x and a 2x, a 2y and a y. All right, so I've got to choose a variable here. Okay, I am going to choose y. Okay, and multiply equation 2, multiply this one by 2. Y. 4x plus 2y is equal to 64. Now can you see I've manipulated them so that I've got a 2y there and a 2y there. As long as I multiply both the equation right through by 2, it doesn't make any difference to the equation. So what is my next step? My next step is then write them underneath each other because the equations have got, the fractions have gone. And I say 3x plus 2y equals 60 and 4x plus 2y is equal to 64. Now I say that's equation 1, it's equation 2. I've done my manipulation here. The manipulation was done at the top there. So when I get here, I'm ready to rock and roll, right? So I can now automatically say, okay, just what am I going to do? Now ask yourself, do I add or subtract? Check it with your calculator if there's minus signs, right? If this was 2y and it was minus 2y underneath, okay, like 2y and a minus 2y, then, okay, you would add them. So you'd go minus 2 plus minus 2, and you'll see it gives you a 0 at the end of the day, right? Okay. Let's have a look here. Now we say, okay, I'm going to subtract, so I get minus x equals minus 4, x equals 4. Take that and back substitute. Right? And when I back substitute it, then it means that I've got an answer for my equation. Right? So eventually I end up with x equals 4, and then let's just complete it. You go 2x plus y equals 32. Therefore, 2 times 4 plus y is equal to 32. 8 plus y equals 32. Y equals 24. So my coordinates are 4 and 24. That's the point of intersection of those two graphs, right? There's a few more I'm going to do with some other fractions that come into it. I'll deal with those in a separate one, okay? Because I don't want to sort of go over into, because if I start going on these, they're going to take a bit long. So what we do, okay, how do we solve simultaneous? First of all, we write the two down. The next step is we write them in standard form. Something x plus something y is equal to a number, and something x plus something y is equal to a number. It doesn't matter, okay? It doesn't matter if you've got fractions or not. You still write them the same way, okay? Now, the next step is then to say, okie dokes, now I've got that. Then if I've got fractions in the denominator, I remove the fractions by manipulating the equations at the top. So I'd say, right, remember, let me just sketch this schematically over here. We've got equation 1 over here and equation 2 over here. We remove fractions. Do it here and do it there, right? So you get a new equation over here and a new equation over here, right? But the fractions have gone. How do we remove the fractions? We multiply by LCD and by LCD over here, all right? The LCDs are different. It doesn't matter. Now we get two equations here. Then you choose a variable that you're going to eliminate. Choose the variable, either the x or the y. Then check if I've got 3x minus 5y equal to, let's say, 20, and I've got minus 2x plus 8y equal to minus 25, all right? What do? Well, I decide, am I going to choose the y or the x? I'll probably choose the x here because the numbers are smaller, okay? What does that mean? I'll say, oh, hang on, that looks a bit messy, okay? It looks a bit messy, so what do I have to do? I have to move it away, and I have to say, all right, I've got to say, that's not right. So times that one by 2, which gives me a 6x minus 10y equals 40, and multiply this one by 3, minus 6x plus 24y equal to minus 75. Now what have I done? I have got that chosen variable by multiplying by the LCD, by 3 in that case. We have got that chosen variable to be the same. Then we put them under each other in the form 1 and 2. And then we go to our calculator and say, now, must I add or subtract? Can you see I've got plus 6y minus 6y here. So these equations, I must take equation 1 plus equation 2, okay, to get an answer for that. All right? That's the scenario. That's where we go with those characters, right? We're going to use that method to go through it. In the next one, I'm going to finish off, do that other one the other way, okay? And I'm going to do a couple more involving some more serious fractions so that I can move on to inequalities, which is the section after this, okay? I'll see you in the next one, and as I say, we'll do some more complicated one. Cheers, see you later, bye.